part, it's about series and parallel circuit. Okay, so in a series circuit, what is a series circuit, by the way? Series circuits are, um, we said current comes from the battery, right? So the current, the battery provides the push force in the within the wires, so the current flows through this direction. So it goes from here to the conventional current. Okay. Now series circuits are one that has one loop. If you have no bridge between them, no path that current can go through except one direction or except one loop, then it becomes a series circuit. So let me give you an example. So for instance, if you have something like this, I want you to type it in the chat. What do you think? Is this series circuit or is it a parallel circuit? Type it in the chat. What is this? Is it a series circuit or is it a parallel circuit? Type it in the chat. Yeah, Zainab? Yasin? Yeah. Okay, so most of you are getting this one right. In fact, all of you. So the reason why you said it, it's because it's still one loop. All right. If it's one loop, it's said to be a series circuit. But if you put a bridge in between, current can now flow through here, and then it can flow through here. Once it gets it. Now remember, these particles do not have brains. Yes, they just follow a system. So they go through here, all right, and then going all the way around, there's more resistance. So the easiest option is to go through here, and that's what they will do. They will flow the easiest route. Okay. Okay, fantastic. So that's series circuit. Now, in a series circuit, few things that you need to know. Uh, we said it's a closed circuit, all right, so it's basically one loop. Current only flows a single path. We talked about that. The current is the same everywhere. Now that's important. Current, we measure current in amperes or amps. Notice here the current is 0.5. Notice here at this point is 0.5. Notice here it's at 0.5. And also we measure current in ammeter. All right, and that's why you see that next to the ammeter you have 0.5. So all the way it's 0.5. In fact, anywhere in the circuit the current is 0.5. And then it says the total resistance is R plus R1. Now, if you want to work out the total resistance, you just add up the individual resistance. So for instance, let me give you an example. You want to work out what is the total resistance in this circuit. You want to know what's the resistance here, R1, what's the resistance here, R2, and obviously we measure those using a resistor, yes. So you would place a resistor there. Now you just need to add both of them to work out R1 and R2. This would give you RT, or resistance, yeah, the total resistance. Okay, very nice and simple. If you get a series circuit, you want to work out what's the current. Current stays the same anywhere. All right, so you just use what you have been given, or you work it out. So you could be given, for instance, they ask you to work out current. Remember the equation for current. To get it, you need V over I. So what's the voltage? What's the current? Divide one another, you get the resistance. Okay, and you want to work out or rearrange it to make I the subject. So it's V over R. Okay. And that's what all you need to do. Current stays the same. And then they tend to ask you, work it out. For instance, part A, work it out, the current, by rearranging the equation. That's all you need to do. 2 marks or 3 marks, okay, with the units. Part B, they could say to you, what would it be here, this position? You just need to say 0.5, because whatever that you got from the previous, it will be the same because of this. Current stays the same everywhere in a series circuit. All right, so that's what you need to know. Now, in terms of parallel circuit, so let's have a look at it. Now, here's a parallel. How do we know it's a parallel? It's not a single loop. There's a bridge or a different path. Current flows through. Current is very lazy. Rather than going through all the way here,